Most of what we've talked about so far has been atoms in isolation. We have thought about the number of electrons and protons and neutrons and the electron configuration of atoms. But atoms don't just operate in isolation. If that were the case, the whole universe, including us, would just be a bunch of atoms drifting around. What begins to be interesting is how the atoms actually interact with each other. And one of the most interesting forms of interaction is when they stick to each other in some way, shape, or form. And this sticking together of atoms is what we are going to study in this video. Another way to talk about it is, how do atoms bond? Now, as we will see, there are several types of bonds, and it's really a spectrum. But let's just start with what I would consider one of the more extreme type of bonds. And to understand it, let's get a periodic table of elements out right over here. So let's say that we are dealing with a group 1 element, let's say sodium right over here. What's interesting about group 1 elements is that they have one valence electron. If we want to visualize the valence electrons for, say, sodium, we could do it with what's known as a Lewis dot structure or a Lewis electron dot structure, sometimes just called a dot structure for short. But because a neutral sodium has one valence electron, we would just draw that one valence electron like that. Now let's go to the other end of the periodic table and say, look at chlorine. Chlorine is a halogen. Halogens have 7 valence electrons. So chlorine's valence electrons would look like this. It has 1, 2, 3, 4, 5, 6, 7 valence electrons. And so you can imagine chlorine would love to get another electron in order to complete its outer shell. And we've also studied in other videos these atoms, these elements at the top right of the periodic table, which are not the noble gases, but especially the top of these halogens, things like oxygen, nitrogen. These are very electronegative. They like to pull electrons, hog electrons. And so what do you think is going to happen when you put these characters together? This guy wants to lose the electrons, and chlorine wants to gain an electron. Well, maybe the chlorine will take an electron from the sodium. Now, in a real chemical reaction, you would have trillions of these, and they're bouncing around, and different things are happening. But just for simplicity, let's just imagine that these are the only two. And let's imagine that this chlorine is able to nab an electron from this sodium. So what is going to happen? Well, this sodium is then going to become positively charged because it's going to lose an electron. And then the chlorine is now going to gain an electron. So it's going to become a chloride anion. Anion is a negative ion. It's a sodium cation, a positive ion. Ion means it's charged. And now it's a chloride anion. So it has the valence electrons that it had before. And then you can imagine that it gains one from the sodium. And now it has a negative charge. Now, what do we know about positively charged ions and negatively charged ions? Well, opposites attract, Coulomb forces. So these two characters are going to be attracted to each other. Or another way to think of it, they're going to stick together. Or another way you could think about it, they are going to be bonded. And they will form a compound of sodium chloride. And notice, the whole compound here is neutral. It has a +1 charge for the sodium, a -1 charge for the chloride, but taken together it is neutral because these are hanging out together. And this type of bond between ions, you might guess what it's called. It is called an ionic bond. Ionic bond.